No, actually, that's the essence. Yeah, it's like a computer.
Okay, so I guess we can continue now. So there's some extra dynamic programming problems from Google Code Jam. Google Code Jam is a competition which is ran every year by Google, and you can test your programs on the previous instances. So now let's move to planning and the planner module. So planner module is just based on tabling. You don't explicitly use table when you use planner module, but it's used under the hood. So let's start with a simple example. So for this problem, the problem is that you get a number, an integer, positive integer as an input. And you want to find a shortest number of operations to transform number 1 into this input number. And you have two operations. One operation is doubling, and another operation is decrement. So let's have some example. So to output 5, the shortest way, one of the shortest ways to do it is double decrement, double decrement. It should be correct. So let's try a simple thing. For 2, it's just double. For 3, double 2 times and decrement. So looks correct. And how you actually encode this is a planning problem. First line is just import planner module. And then you need to have two special predicates. One predicate is final, and it's true when you reach your goal. So here we have our state. State is a tuple of current value and the goal. So for this problem, I decided not to use this global map. I just put this goal as a parameter. I could use global map again. So we reach our goal when current value equals to our goal. And there are two rules for action predicate. You may notice this question mark here. This is notation. So basically, without question mark, the first rule that match the parameters will fire, and the second and third and so on will not fire. So it's like having cut operator in Prolog without having this question mark. Okay.
So do you specify the question mark here on all predicates except for the last one then, essentially? They would match the same?
Yes, if it will match the same pattern. So we have the same pattern here, so we need to specify question mark until the last one. If it will be different pattern, if it's like 0, for example, for the base case, We just put 0 for pattern matching. We don't need to put question mark. It's no big deal. You can put question marks everywhere. It's like not a huge performance issue, but like it's cleaner and a little bit of performance issue. So action predicate has 4 parameters. First parameter is the current state. Second, current state before action. Second parameter is the state after the action. Third parameter, just name of the action. And the last one is just cost of the action. And cost must be greater than 0 because of the underlying algorithms. If you use cost less than 0, you will have random results, basically. Sometimes you will get correct results, sometimes not. It's because Dijkstra shortest path algorithms also works with positive length. So for the first clause of action, the name of the action is double. Cost is 1. We don't care for us for this problem. All actions have the same cost, so we just put 1. And what is new state? New state is current number times 2 and goal. So it's like a tuple, just a 2 tuple. And the same as for decrement action. So it's should be pretty obvious. And the main, we just read integer and run best plan predicate. Best plan predicate defined in the planner module. The first parameter is initial state. Current number is 1, goal is our input goal. Plan is the output parameter. And after that we just output our plan. So that was really simple. I want to show you a little bit more complex thing. Word search puzzle. So you have grid of letters and you want to find words in this grid. You have a word, the word is given, you want to find this word in this grid. And you can use vertical, horizontal, diagonal, and from left to right, from right to left, any direction in straight line. So this is my program for word search. And I prepared an input file for it. So first 2 numbers is just number of rows and number of columns in our grid. Then we have our grid. Then we have an empty line, and we have a word we want to find. So I want to show you the output of my current program. It's intentionally not correct. So the first answer is like looks correct. It finds haha. This is not correct. So what it found for this input is just basically first letter, this letter, and this letter again. So this is not allowed in word search, but my current program allows this. Here the same issue. First, second, and again. And we have several such occurrences. So let's look at what it actually does. So this is the state. State is, so how to pose this as a planning problem. So our output basically will be indexes of, for each letter we use in succession. Our plan will be row for this letter and column for this letter. So for example, for this output, actual plan will be list of 4 tuples. The first tuple will be 2, 1, second row, first column. The second tuple will be 2, 2, and so on. So it will be like this. This is the actual output of the planner, but for output of the program, I transform this output to a nice representation. And in this program, the state is current row and current column. So it defines current cell. And current cell is where the last letter of the word was put. This is the actual word. Again, I don't pass it as a global, I pass it as a real parameter. And I is the index of the last letter of the word we already processed. So final means we don't care what is the current position of the cell. So this is underscore R means, so if I meet underscores, Picat will complain that these variables are not used inside the body of the predicate. So I can put just underscores. Underscore means don't care variable. And this names the same, this looks the same, but actually these are 2 different variables. So it's convention for Prolog and for Picat. All variables named underscore, actually different variables. But for documentation purposes, I put underscore R, underscore C. So what this final means? When our I, the letter we already processed, number of the letter we already processed, equals the length of the word, we're done. And again, remember this is one indices are 1 based. Everywhere in Prolog, indices are 1 based. And we have actions. The first action, it's for putting the very first letter of the word. We can put it anywhere. if it matches the grid. So our example, we can put H anywhere H is in our grid. Row and column are 0 for this pattern to match, and 0 means in this program just we haven't placed anything yet. And 0 here again means the same. So we get board as a global parameter. We get number of possible rows, number of possible columns. Just because it's 2D array, we can do this way. And we have between. Between is just non-deterministic predicate that assigns to the third parameter all values between first and second parameter. So basically we loop through in a non-deterministic way through all possible cells in the grid. And if the letter at this position equals to the first letter of the word, first because it's like this whole action, whole rule for putting only the first letter. The cost is 1, we need to have a cost. Even if we don't care about like the length of the plan, if we want to try any plan, we need to put something for cost, and 1 is good as anything. And action. Name of the action here actually a tuple. Position of this cell. And new cell will be first two parameters. Coordinates of the cell we just used. The word is the same. And 1 means we already put 1 letter. And this is the general case. First several lines are the same. There are guards, just in case so we don't get past the word. And we want to, from a letter, we want to be able, from a letter we already put, we want to be able to get left, right, down, and diagonally. So this is a member predicate. That's again, RD means difference in row, difference in column. And as you can see, we can use pattern matching inside member also. We can use pattern matching almost everywhere. And this is non-deterministic. So basically, we try all neighbors of the current cell. All 8 neighbors. And if this letter is what we want to find, we continue. And main is just reading input and output the board. And here we can see for this program I want to output all possible solutions. So if a word is occurred several times on the grid, I want to output every occurrence. So for this I use so-called Feeldriven loop. So it finds, and I use best plan non-deterministic. It's a different kind of plan predicate. For each number I used just best plan. It just outputs one best plan. For best plan non-deterministic, you can output all of the plans, all of the best plans. The plans with the best score. And really all our plans will have cost before, because we have the same cost because the length of the word is the same. So there is no need to use best here, but it's no harm. So basically I am finding one plan, I output this plan, and I fail. And after the fail, it tries to find the second plan, and so on, until there are no more possible plans. And after that, it goes to the second disjunction rule, just true. I need this to not fail the whole program. I don't want to have the whole program fail. It will work even without this. It will output everything, but it will fail at the end. You can try it. So this is failure-driven loop, and it was pretty common in Prolog. So basically, I want you to do these exercises. I want you to fix this program. And by fix, I mean look for words only in straight lines. So how can you do this? So basically, you need to introduce one more parameter in our state. And this parameter will be the direction of the previous action. And the direction should stay the same. So yeah, please try this. I think it's not too hard and kind of interesting. So for our example, the Fixit program should only return one answer, basically. For this example, it should find only one answer. This. How do you run?
Yeah.
Yet. To run, just Picat, name of the Py file, and use std in redirect. To output content of the file to the program. And just a standard shell stuff, it's not Picat related. So basically your state will be not 4 tuple but 5 tuple. What?
Show me this for a sec. So I got my trick this one to work, and then I don't think that's my command. Is that right?
No.
Okay.
You just do it from standard input. So just run. Yeah, just put in enter right now, and just output.
Oh, I see. So then I go with
Yes.
this.
You can redirect from file.
And then it's do the list, right?
Just space separated.
Okay.
But I think it's other way around. First you output.
Oh, I see. Okay. Impossible. Okay, so let's try it again. And then it's the list. Okay.
Yeah, just how I designed it, so
Yeah, yeah.
it's you can design it in a
Yeah, I
different
got
way.
for some of that is going to even into. Okay, perfect.
Yeah.
Thank you.
Again, feel free to raise your hand, and I'll help you if you're stuck. Yeah, but actually, for direction, you need to compare for equality, right? So you can just use one number for that. So we have like 8 possible statements, so we can just have 8 possible directions for each name.
Yeah, since translation means you try to do some arithmetic stuff with variables.
So like, I guess this presented like this already
Yes, so this doesn't say like what lines.
usually this, and I don't really
From minus. Should have minus.
I don't know. I did this.
Is there any D in the main?
Yeah, I mean, just, like if I remove the if from this type of number, it prints out where it needs it for, because I keep it out. I guess I'm confused with like equals versus equals.
Okay, so equals it's equality if it's equal, you will succeed. One equals means you try to unify it to the, so if with two equals you don't change it. One equal you can change values.
Okay. I think I should switch to because I use this first pass. I guess.
Yeah, but
I
only to start the stuff together.
okay.
Because
It doesn't complain about syntax.
Okay.
Of course. Even if there's something like maybe it'll be nice now and say here with Hugo.
Well, we also should. But I should be able to.
Free variable expression. So it means you use some way of variable where don't assign value.
No, I mean, for when I go. Yeah. Oh, sure, yeah. Maybe it's there. Honestly, anything. I guess we'll just pretty flat. About 40 minutes. Yeah. And then 40 minutes. Yeah. Well, you have jet lag.
Works? Okay, so I saw some people already did this, so I'm going to show how I did it. So basically, I had one more parameter to my state, it's just direction. For the first thread, I don't care about direction. And we can use something like this. So I saw people used to tuple for direction, but actually we care only about if our directions are equal or not. So we can just use one number or just some symbols. So to be more descriptive, we can use like descriptions for this will be right, this will be down, this will be left, this will be up. You can use anything as long as it's different. You can use tuples, you can use numbers. The only thing you need to use different thing for each of different directions. So this will be up, left. This will be up, right, down, left, down, right. And this will be our new direction. And after the first letter, I put a special direction any. So we can check for this using disjunction again. So either our current direction any, or our new direction equals to our current direction. I also notice it's kinda clunky to use this tuples for state. It was okay for 4 variables. It's kinda okay for 5 variables, but more variables it will be like unmanageable. So we can use structures and hash tables to have state, but for simplicity I use just tuple. I'm sure I made some mistakes, but let's try it. Yeah. I have no answers because I made some mistakes. So let's try to debug it. Have anybody spotted a mistake I made?
Maybe action, you have underscore missing on the second action. Third action file, then action, and your RCWI, VIR, underscore.
In the second action block, does the quality check need to happen after the method calls, or can that happen?
Yeah, so yeah, that's the problem. So here new direction is not initialized yet, and I use equality checking. So I can use a unification here, and it should work. So unification, it tries to unify variables. So if one of the variables are not initialized yet, it will become equal to the other variable.
Sorry, maybe I'm misunderstanding. But I thought there you were checking to see if the old direction is equivalent to the new direction.
Yeah, I changed 2 equals to 1 equal. For 2 equals, it actually compares 2 variables. And at this point, our new direction is unbounded.
Okay.
So it fails. But if I use now 1 equal, it means different operation. It means unifying.
Okay.
So at this point, new direction will be. So it's a little bit confusing because it's not new dir equals to dir. It's other way around. But it's the same. For unification, both parts are equal.
Okay.
So now we have our answer. And if you want some challenge, you may try to use any word shapes, not only straight lines, but don't reuse letters. You will need to pass a hash table or something to keep track of what letters you already used. And there are a couple of examples of planning problems from Google Code Jam. The first one is really simple. If you're interested, try it. It shouldn't be too hard to solve if you've done word search. This one is much simpler than word search. So, okay, so for more info about Picat, go to official site. It has a lot of pointers to documentation. Picat documentation you download with Picat system is also really good. Also, there is a book, recent book, 2015. This book is a little bit more in depth, but it's really good. And the third pointer is examples by Hakan. There are a lot of examples. They're a little bit messy, but they have examples almost for any puzzle or any riddle, I don't know. A lot of examples if you are willing to look at what's possible. Yeah, so basically that was my last slide. Any questions?
The code, your code answer up again.
So I guess, when would I use this programming language?
Okay. So it's not mature yet, right? So I don't think you are going to use it in production, but I know some people use it like for game levels generation, for like artificial intelligence inside there. So what's good about this? That you can change pretty easily your logic. If you want to adapt this word search to a little bit different kind of word search, it's easy to do. The same is like for game programs. If they change their puzzle logic, they could quickly adapt it. So, yeah, good for.
How good is the performance like, compared to other systems?
Yeah, performance is pretty good. So this is based on B-Prolog, and B-Prolog is one of the fastest Prolog implementations. It uses a special so basically this is compiled into bytecode and is run on abstract machine that is optimized to run Prolog code. And Picat code basically transformed to the same bytecode. So it's pretty fast. It's not C fast, but yeah, it's pretty fast.
What kind of memory consumption does the table have?
So, yeah, of course it has some memory consumption. It's not magic and it's not compile time. And so, but it's done in pretty clever ways. So it tries to do a thing called sub-goal subsumption or something. I don't remember exactly, but there are several papers. There are different ways to do tabling in Prolog and logic programming. And Picat uses a thing called linear tabling. If you're interested in this, you can look for linear tabling and you will understand more about it.
I think you said some of the strengths, if you said what were things that would be before you might adopt it a little bit more, would you say maybe libraries? I'm just guessing.
Yes, maybe libraries. Because, for example, recently I needed to read an image file in the Picat, yeah? And there is no image file libraries. I was able to fall back to really simple image format called PNG, I believe, I don't remember exactly, where you just read bytes, but it's not efficient. Yeah, more libraries, more adoption, because you need to test stuff, right, to find bugs.
Is there any kind of namespacing for libraries?
Yeah, there are modules, but they're really raw, so you can create modules, but it's kind of rough.
Is there a language feature that people are used to in Prolog that Picat just doesn't have but wants to have?
Yeah, there is a feature people are used to in Prolog called context-free grammars. And Picat don't have this, and will not have this probably, because of reasons.
How did you get involved with using Picat?
I was active in Prolog community, so when I saw this Picat language creation, I jumped in. It has some stuff that is better than Prolog stuff.
The implication error on these predicate clauses seems to point the opposite direction than these two in Prolog. Is there any significance to that? Or?
I'm not sure.
I guess it needs to be like having the arrow pointing at the head of the clause with the LV.
Yeah, you mean less than and
probably just the, I guess in between it looks like a predicate, with an arrow that knows clauses.
Yeah, but in Prolog you just use this. Yeah, it looks
Yeah.
like. It's just an arbitrary choice. I don't think it's significant.
Have you heard of the Mercury programming language?
Yes, I heard about it, but I haven't tried it really. So, yeah, I know it's like a hybrid of functional programming and logic programming. Yeah, it also has. I know Mercury has also a lot of good stuff like constraint programming. I haven't talked about constraint programming in this talk, but Picat also has constraint programming. More questions? Okay, thank you. I hope you got interested in Picat and tried for your problems, even toy problems. Thank you.
Thank you.